2018 Exam 1, Question 7. Okay, so we've got ourselves a precedence table with activities, duration times, and immediate predecessors, and it wants us to work out the minimum completion time for this project in hours, so we're probably going to draw out the diagram and then do critical path analysis. Okay, here's my rather wonky diagram. It doesn't have to be perfect for the exam, you're not being marked on that. But here we've got A, because it's the only one with no immediate predecessors, and then we've got B, C, and D, because B, C, and D all have A as immediate predecessor. Then we've got E requires B, so that's going across there. Then we've got F required C, then G required E and F, so they join up again over here. And then H was off from D, and then I needed G and H, so they get bent up and joined here, and then we go just through I to the finish. Okay, so just going to do my forward scanning. This is 0. Now B, C, and D all get 4, because that's the A is 4. Then across the top here, 4 plus 3 gets me 7. Then 4 plus 7 gets me 11, and here 4 plus 2 gets me 6. Back across the top, 5 plus 7 is 12, 2 plus 11 is 13. I choose the highest number, 13. 6 plus 5 is 11, 13 plus 4 is 17. I choose the highest number, 17. 17 plus 3 is 20. So the answer is 20. Important to note here, once you've answered the question, you don't have to do the backward scanning. There's no requirement for float. So, question answered. And when I look at the answers for this one, about half the students got this right. 2022, Exam 1, Question 7, and Question 8. So we have a whole precedence table. It's even got the ESTs on there to help you out in case you get your diagram wrong. And they are asking us about where a dummy is going to be. And we can spot the dummy because here we've got D, E, and E. So similar overlapping immediate predecessors, but there's obviously a difference between them. And we've got F and G. And simply all you have to do is think about the fact that we have this repeated one, E, so it's going to come from E to the one with the most IP, which happens to be F. So it's going to be from E to F, which is answer B. And people did okay on this one. They got about half of people got that one right. Now, you could also draw out the diagram, and this has got a question 8, so you might have to draw out the diagram. Let's just do it the drawing diagram way as well. Okay, when you try and draw the diagram, and you haven't got a pre-printed, beautiful, neat copy from Vika on the answer sheet, you'll end up with horrible, messy things like this. But you can see that if you go backwards from F, you can go backwards to the dummy through E, but you can also go across the top here into D. But if you go backwards through G, you only go through E, and that's what we wanted to see in this situation. But you might need the diagram for the next question. Okay, so we're going to do the forward scan, adding for the biggest number. We've already got the ESTs actually here, but we're going to do them anyway. Nice to confirm you're getting things right. Put our zeros. 0 plus 6 is 6, so 6 and 6. Down the bottom here, you've got 7. 7 plus 8 is 15. That means we've got a 15 here, and 6 plus 7 is 13. We choose the biggest number, which is 15. 15 plus 2 is 17. Across the top, 10 plus 6 is 16. Let's keep going down the bottom. 15 plus 2 is 17. That must mean this is also 17. 17 plus 3 is 20. I'm going to choose 20. 20 plus 6 is 26. 17 plus 3 is 20. I'm going to choose the 26. 26 plus 2 is 28. Whew. All of those numbers do actually match, I hope, with the ESTs over there. Now we're going to do backward scanning. This is going to be 28, because that's where we're starting at. 28 minus 2 is 26. 26 minus 5 is 21. That's just for the J path. 26 minus 6 is 20, so that's going to be 20 here. Now, 20 minus 3 does give us 17, so it looks like H is on the critical path. Choosing my lowest number of the 17 and the 21, it's 17. 17 minus 2 is 15. I'm going to put it in the box because it's not going to be lower than 15. It's not cheating or anything. 20 minus 2 is 18. If you go down the dummy, you do get the 18 is there, and that 18 and 15 means that you did choose the 15 correctly. 15 minus 8 is 7. 7 minus 7 is 0. It looks like we've got our critical path here. Let's just work out all the numbers because we need to work out the floats because we want the sum of all the floats. So 18 minus 7 is 11. And then if we go over the top for C, C we need to go, what was it, 20 minus 10, which is 10. And then we've got the choice between 10 and 11, so we choose the lowest number. So 10 minus 6 is 4. Now let's choose a nice color for our floats. Now let's do the critical path. Let's just highlight that. Where's the critical path? So the critical path is here, here, through here, and here. So the floats are on A, C, D, F, and J. I'm going to use orange so you can see it. So that means we've got 4 here, and we've got 5 here, we've got 4 here, we've got 3 here, and we've got 4 here. That's all the floats, 1, 2, 3, 4, 5. And then if you add them all up, that's 4, 8, 11, 16, 20. The answer is D, 20. Now, looking at what people did last when they did this exam, and this is question 8, it was answer D. 34% of students got that right, so there's a bit of a spray and guessing there. 2017, Exam 1, Q4 and 5. Okay, quite a complicated graph here, and we've got to work out the EST of activity N. So we're going to do a forward scan and put all our boxes in. I think there's other questions coming up, so we might as well do the whole critical path analysis. All right, we're just going to aim for N for this point. So N is down in this bottom corner, but we need to have some zeros here because they're all at the start. If you're coming down the bottom here, 0 plus 4 is 4, so these all start with 4. This is quite a complicated one. So we come down here, we get 4 plus 3 is 7, so I've got some 7s there. 4 plus 6 is 10. 7 plus 2 is 9. So I'm going to choose the 10s for these. 10 plus 1 is 11. And then 7 plus 5 is 12, so I get 12 for N there. And that was the correct answer, D12. Bit of sass from VCAR on this. While there was some complexity in the activity network, students should be able to apply standard routine calculations to graphs, such as this, with care. Thank you, VCAR. Always a help. Okay, with our forward scanning complete here, pause the video if you want to try and go and get the same numbers. Let's start with our backward scanning. So 17 minus 6 is 11. 17 minus 4 is 13. 17 minus 1 is 16. 16 minus 3 is 13. 13 minus 3 is 10 for H, but it's 13 minus 1, so it's 12 for K. 13 minus 5 is 8 for J. And then for I, it's going to be 10 minus 2, which is also 8. Then we've got 8 minus 3, which is 5 for G. Then we've got 10, because out of the 10 and the 12, we choose the lowest number, 10. 10 minus 6 is 4. Looks like we're getting a critical path there. Let's go back up the top. So 11 minus 1, 10 is 1 for A. 11 minus 5 is 6 for D, but 13 minus 4 is 9 for E. And then B, choose the lowest number, 6. 6 minus 4 is 2, and C, 4 minus 4 is 0. So we're going to highlight the critical path. And so if you look at this, C has got 0 to 0, so there's nothing floating there. F has got 4, 4, so there's no float. H has got 10, 10, so there's no float. And M has got 13, 13, so there's no float. So it's 4 activities, so the answer was C, 4. And about half the kids got that right. Quite a bit of a spray. People got a bit lost. Definitely something to learn in critical path analysis. 2019, Exam 1, Question 8. Okay, so we've got to work out the number of activities that have a float time of 10 hours. So we're going to have to forward scan and backward scan, EST and LST. Let's go draw those little boxes. Now, okay, forward passing time. So 0, all 3 of these are 5, 5, 5, 5. 5 plus 4 is 9. 9 plus 3 is 12. Those are all 12. Now for D, you can see the boxes all the way down here and then back up here. So that's D plus 1 is 6. So these both start at 6. C is 5. 5 plus 7 is 12. 12 plus 4 is 16. 6 plus 3 is 9. I'm going to choose 16. 6 plus 8 is 14. 12 plus 6 is 18. That's 18. 18 there. So I'm getting that all right. 16 plus 5 is 21. 18 plus 6 is 24. I'm going to choose the 24. 24 plus 7 is 31. 18 plus 5 is 23. 12 plus 7 is 19. 19 plus 2 is 21. I'm going to choose the 31 to start P and Q. 31 plus 8 is 39. 39 plus 1 is 40. 31 plus 11 is 42. I'm going to choose the 42. 42 plus 9 is 51. Now for the backwards. So we're going to go in red. 51 minus 9 is 42. That makes sense. It should be on the critical path. 42 minus 1, because we're just doing the R, is 41. 41 minus 8 is 33 for the P. And that makes sense because you've got 9 over the PR and just 11 on the Q. So the 42 minus 11 should give me the 31 because Q is on the critical path. 31 minus 7 is 24. That looks like that's the critical path there. We're choosing the 31. 31 minus 2 is 29. That's a float time of 10. I like that one. Hopefully that was one of them. 29 minus 7 for I is 22. I'll just redraw that. That was terrible. 22. So that means we've also got a float of 10 there on I. Let's do some more of this lovely diagram. 24 minus 5 is 19. 24 minus 6 is 18 for K. Must be 18 there as well somewhere. Because there's 2 coming back in there. So for M, we've got to do 31 minus 5, which is 26. Choose the lowest number. So 18 minus 8 is 6 is 12. So that looks like the critical path goes up the top there. 12 minus 3 is 9. 9 minus 4 is 5. Why am I going wrong here? 5. There we go. Yeah, the boxes are all over the place, aren't they? 5 minus 5 is 0, so there's the critical path. Whew. It really is a stress. Now, where were we? So 20, we had down the bottom here, 24, that was a 19. So 19 minus 9 is 16. That looks like we got another 10 there. And then for the F, it is going to be the lowest number at that point, which actually is the 18. 18 minus 8 is 10. Then we choose the 10 minus 1, which gives us 9 for D. This is a horribly big diagram. 19 minus 4 is 15. 15 minus 7 is 8. There we go. And we know it's going to be the critical path over there. So it looks like just those three activities, G, I, N, are the ones with the critical path. And so the answer must be D. It's a question 8. You've earned your mark for that one. 2020, Exam 1, Question 6. Okay, so we need to work out the minimum completion time for this project, which means you only need to do the forward pass, because you need to do the backward scanning to work out the floats. So this just means you need to do the forward pass. Okay, just that fun reminder that you start with 2 boxes here, because it splits into 2, 2 boxes here 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 because it splits into 2, and don't forget the unlabeled one for the finish at the end. All that, those boxes. So we're just going to use our green pen. We're going to start with zeros. 0 plus 7 is 7. 7 plus 4 is 11. That's going to mean we're going to get 4s here. 4 plus 6 is 10. We choose the bigger number. That's going to be 11. 11 plus 3 is 14. So there's a 14s. 7 plus 8 is 15. 14 plus 3 is 17. I'm going to choose the 17. 17 plus 5 is 22. 14 plus 6 is 20. Now, what do we got? 11 plus 3 is 14. 4 plus 2 is 6. 6 plus 9 is 15. I choose the 15 up here. 15 plus 5 is 20. I get 22. So the answer is E, 22. 2023, Exam 2, Question 14. Now we've got this precedence table here. It's got a couple of grey spots because that's the answers for A and B of this thing, and you can see we've got this dummy here that hasn't been mentioned in this, because normally when you've got a dummy there should be some sort of conflict in the IP. Let's just highlight what's going on here. So I to G, but also I through the dummy to C, and so that's why you should have C, comma G there. So the answer is what the immediate process C, comma G. Do not write down the dummy unless you are a dummy. That's the trick they're trying to play on people there. Now, we've got to work out the earliest start time in days for activity J. Now, you could be quite smart here. Because you've got this EST thing, you only want to do for J, that's to say you weren't doing any more questions. You could just do the straight out box here for H and the box for over here for E. Now you know E has an EST of 4, you know H has got an EST of 9. 9 plus 7 is 16, so there's your J box, and 4 plus 10 is 14, so you choose 16. So you didn't have to do the rest of the diagram. The answer was, in fact, 16. There you go. Okay, it says how many activities have a float time of 0, which means how many activities are on the critical path. So we're going to do our backward scanning. Done all the forward scanning here. The main part to pay attention to is around this dummy area. We've got a 9 plus 3 coming up here, which is 12, but then we've got the 6 plus 7, which is 13 coming in here. So it's 13 for the start of F, but also 13 for the start of I, because remember, that's why we have a dummy. So let's do our backward scan. So let's start with our 24. 24 minus 1 is 23. 23 minus 4 is 19. 19 minus 4 is 15. So there is a float on F, but then 19 minus 6 is 13 for I. Now this is where it gets a bit weird, because then the 13 and the 15 are actually both here because of the dummy being 0. So we choose the lowest number, which is 13. 13 minus 7 is 6. 6 minus 6 is 0. Looks like that's the critical path. Let's just finish off the whole thing anyway, because it's fun. 13 is the lowest number there, so 13 minus 3 is 10 for G. But then we're going to come down the bottom here, so 23 minus 6 is 17. Then we're going to go back up through the H, so 17 minus 7 is 10, so there's also a float of 1 on there. 17 minus 10 is 7, so that's 7 for E, don't have to put it there, that's what erasers are for. 10 minus 5 is 5, 5 minus 4 is 1, and let's highlight our critical path. So A, C, now F has got a float on it, so we go through the dummy I, K, L, and if we count them correctly, and again, let's not be a dummy and count the dummy, so that one doesn't count, so it's 1, 2, 3, 4, 5. So our answer is 5, and I think it says here some people erroneously counted the dummy activity, so that's probably where I got 6. Only about a third of students got that right. Okay, so this needs to be read out aloud because it's very small. If activities A and B, these two here, have their completion time reduced by 2 days each, the overall completion time of the project will be reduced. What is the maximum reduction time in days? Now, all paths either go through A or through B. So if you reduce both by 2, you're going to reduce all paths by 2. Therefore, the answer is 2. Now, it might not necessarily be that way with crashing. So at the moment, your path is through here. Now, but notice, though, that there's actually only a float of 1 all over the place. There's a float of 1, there's a float of 1, a float of 1, a float of 1. So we're going around like that. That's a float of 1. And that's why we get these differences, 22 and 23. So if you only reduced A by 2, the project would only be reduced by 1, because that 23 would become 21, and you'd have a new critical path. So that wouldn't be the critical path anymore, because that would be the 22 would be winning, you see? So this is the thing you have to think about with crashing. But since both A and B have been reduced by 2, all paths are reduced by 2, the whole project is reduced by 2. The answer is 2. Now, only a third of students got that right. Some people rather mistakenly gave the answer that the new project time would be 22, because obviously the end here would become 22 down over here, but the answer was 2. This is what you have to do, is you have to just work out the logic and balance these things out and looking at floats and things. Fun questions. Now, these are very tricky questions. Only 9% of people got this right. Here are activities we can crash or reduce. We can reduce them by a maximum of 0, 1, or 2 days. And we can have a cost associated with these per day. And the total budget is 15,000. Now, our critical path was along here. And they gave us a bit of a hint that you can actually probably crash A and B by 2 days in part D. So why not do that? So I'm going to cut this down to a 4. Now I'm going to change all the other numbers that happen with this and then recompare them all the time at each little junction. So 4 plus 7 is 11. So this is 11. This means now that the 12 is winning here. So it's 12 plus 6. It's going to change that to 18. Then 18 plus 4 is going to change that to 22. And then these two are going to match up. So you can see that 12 plus 6 is 18. 18 plus 4 is 22. So now the project takes 23. I've just done A by 2. That's 2 times 1500, which equals 3,000. That's how much I've spent so far. Now, because there's a float of 2 on F, and we can only crash really I by 2, it's not really point in doing F if you follow through the logic, so don't bother with F. Now let's just do B, that's 2. So that's 2 we spent there, which is 2 times 2,000 for B. That's another 4,000. So we spent in total, a total down here, I'll put it in at 7,000 so far. 2 plus 5 plus 3 is 10. 2 plus 5 plus 7 is 14. 2 plus 10 is 12. 14 plus 6 is 20. Now that means we've got a 22 and a 20. We can probably crash I to reduce this 22 to 20, and that means all the other paths will be of similar length. So we've crashed A, B, and not F. Let's crash I by 2. That becomes 4. That's crashing I by 2. 2 times 1500. I'll keep doing that. Let's just erase that. That's what erasers are for. That equals 3000. Our total budget now we spent is 10,000. And if we follow through the numbers again, we're going to get ourselves with 15 there, and 15 plus 4 is 19. So we need to do some more crashing along here. Let's crash H by 2, see what happens here. So that's 2 times 1000. If this stuffs up, you just wind it back a bit. So that's another 2000. We've spent 12,000 now of our 15,000 budget up there. So if we crash H by 2, that becomes 5, that becomes 12. That's good because we've got a 12 here and a 12 here. So all those paths are now even. And 12 plus 6 gets me 18. Now at the moment, this is all down to 20 because 19 plus 1 is 20. Whew. Pay attention to this because we've now got an 18 on this bottom path coming in here from all the other places, but we've got a 19 coming from here. So our last bit of crashing, this 19, there's no point in making that down to 17 because then that's the critical path is down here, and we want to just balance it out, crash as much as is necessary. So we want to make that 19 18, which means reducing k by 1 to 3. That makes that 18. Now all paths are equal. That becomes 19. We've crashed k by 1. That's 1 times 3000. That equals 3000, funnily enough, which means we spent 15,000, which makes us feel really good because that's what they said we should do. So that's our little table, because actually what was the actual question was what are the numbers that go in here. So if you put those numbers in there, you'll get that. You might need to watch this a few times or ask your teacher to explain it again slowly. It's crashing. 9% of people got this. This is a good one to get right that no one else gets right. And I think that's enough from me. Okay, I had to rearrange things a bit and squeeze everything on. Now this is your classic crashing problem. This is part D up here, but it's got these costs here. So crashing by 1 day for A costs you 1,500, for B 2,000, F 2,500, H 1,000, I 1,500, and K 3,000. You got a total budget of 15,000, and you got to spend it crashing 0, 1, or 2 days for activities A, B, F, H, I, and K. Now, good thing to start is remind yourself of the critical path, because the first thing you do is crash the critical path. Now, first of all, let's put some floats on here. So we've got a 2 here, we've got a 1 here, got some 1s here, I've got a 1 here, got a 3 here, got a 1 here. Now, because F has got a float of 2, there's no point crashing it, because you can only crash by up to 2 days, and you've got a float of 2, so you can't gain anything by crashing that by 2. So that's going to be a no for F.